So integration apply to trigonometric functions. First things first, we have a c in all these things because it's integration, and we can find the value of c by substituting the values of the given point. Now focusing on integration and trigonometric functions specifically, recap that the differential of sin x was cos x. The differential of cos x was minus sin x, and yeah, this explains why the integral of sin x is minus cos x and why the integral of cos x is sin x. These are the basic integrals which you should remember. Alright, so after that we have sec square x is tan x, and the integral of tan x is minus ln modulus cos x. Remember that you have to remember all of these integrals, basic integrals, and this thing looks like ln modulus because ln cannot have a negative thing. Alright. Similarly, moving on, cot x is ln sin x, and so on. Again, these are the basic integrals which you have to remember. We'll move on to advanced integrals, a little advanced data. So we have sin ax. This would be from the basic integral minus cos and ax. Remember that when differentiating, we will multiply by the differential of this thing. But in this case, since we are integrating, we will divide plus c. And then we have the differential, the integral of cos x is sine. Then we have ax as it is divided by the differential of ax, that is a. And so on. We continue differentiating. The integral of sec square x is tan x, and thus since this is sec square ax, we write ax as it is, and this function is divided by the differential of ax plus c. So you do get an idea of how it works. I'll do a few more examples, such as for tan ax, the integral of tan was minus ln, and we divide this ax. No, wait, we divide the whole function by the differential of ax. Or if we write it down in a neat manner, we could also write it down as 1 over a. Alright, plus c. Then we have cot. So we have 1 over a ln cos ax plus c from the basic differentials. Moving on, here we wrap things up. You do get an idea of how these differentials, basic differentials, can be applied to advanced concepts. And finally, we move on to generalized formulas, or to give you a better idea of what you have to do. So in this case too, sin f of x, the integral would be minus the differential minus, wait, so the differential of sin is cos fx, and we have to divide by the differential, alright, plus c. Similarly, this is cos, the integral of cos is sin, and fx remains as it is, and we divide by the differential of fx plus c. Similarly, here sec square f of x, So the integral of sec square is tan f of x remains as it is, and you divide the whole thing by 1 over the differential of f of x and then a plus c. The integral of tan x is ln cos fx in a modulus, and this is a minus ln, mind you, and don't forget to divide by the differential of f of x. This dash indicates differential. Don't forget to add a c2. Then we have cot f of x. The integral of cot is ln modulus sine f of x plus c, and we have minus 1 over the differential of f of x. You know why? Because you have to divide by the differential of f of x. Because when you differentiate it, you multiply by the differential of f of x. And finally, our last and final generalized formula, you could say. So we have cosec square f of x. Moving up, remembering the basic integral, we know that the integral of cosec square, the integral of cosec square x is minus cot x, and thus we know that it's minus cot f of x. Since this is an function of x in terms of x, we have to divide by the differential of f of x, and don't forget the c. And just remember that the differential of trigonometric functions with higher powers is not part of your A2 course. No, wait. The differential is part of your A2 course, but the integration is not part of your A2 course because it cannot be solved. Alright? So you do have a differentiation of higher powers such as cos x square in your AS course, but you do not have an integration as part of your A2 course because it cannot be solved. Nevertheless, only among higher powers you can integrate sec square and cosec square, and thus they exist. These are the only integrals of higher powers that exist in your course: sec square and cosec square. You will not be asked to solve any other integrals of higher powers, and if you end up with one, that may be an indication that you have gone off in the wrong direction while solving. That's it for now.